Alright, let's start with the next section, 1.5. As you can see, the name is reference angles. What do we mean by reference angles? What we'll do is I'll quickly fill in the blanks and then I'll explain to you what it actually means. For an angle theta in a standard position, the reference angle is the positive. So always keep in mind the reference angle is always positive. Acute, so this is important. So reference angle is always, I haven't explained to you what a reference angle is, but what you need to know is reference angle is always positive as well as acute. And how is it formed? It is formed by the terminal side. We know what is terminal side, right? Of theta and the x-axis. Okay, so from the definition you can sort of make out that it is an angle that has some kind of a reference to the x-axis. Okay, so let's look at what a reference angle is. So reference angle is basically, okay, let me go ahead and draw my coordinate plane. And let us say I have an angle theta here, which is 50 degrees. So the reference angle is always, that's what it says here, formed by the terminal side. So this is my terminal side and the x-axis, which in this case happens to be the initial side. So if I call my reference angle as, let's say I call it as theta, it's called theta reference, is basically 50 degrees from the x-axis. So 50 degrees minus 0 degrees, which is 50 degrees. So you don't even have to do that. I mean, this is kind of irrelevant. So all you need to understand is that the distance from the terminal side to the closest x-axis, and it doesn't matter whether you're looking at positive x-axis or the negative x-axis. The reason why I say this is, let's say I have my theta is 140 degrees. This is my theta now in a second scenario. There's a first scenario, there's a second scenario. In my second scenario, my theta is 140 degrees. So we're talking about this angle. And this is my terminal side. But what is the distance of the terminal side from an x-axis? Not this side, not the initial side. Now we're looking at the closest x-axis. So that's important here. What is the distance of this angle from the x-axis, which is actually 180 degrees. So how do you measure this? 180 degrees. How far are you from 180 degrees? Minus 140 degrees. That is 40 degrees. So my theta degree in this case is basically 40 degrees. This is my reference angle. So reference angle for this angle, for which I've marked with the yellow highlighter, is basically 40 degrees. So what you need to understand is reference angle is nothing but an angle that you measure from the terminal side to the closest x-axis. So here maybe I'll write down, if you want to write this in your notes, the closest one, whether it's a positive side or the negative side, it could be either one of them. What is the meaning of reference angle? The meaning of reference angle is, it's called as a reference angle because for you to be able to refer to this angle, it is this, and I said it's 40 degrees, it is the same as the 40 degrees here. This 40 degrees will have the same coordinates as this angle, which is actually 140 degrees. The reason being, the distance from the x-axis is what matters. Distance from the x-axis is what matters. Just to give it a little more explanation, remember what we said? This 30 degrees, okay, which is basically square root of 3 over 2 and half, because sine theta and cosine theta, this is cosine, this is sine, for 30 degrees is half and square root of 3 over 2, and this 150 degrees, whose coordinates is also square root of 3 over 2 and half, but the square root of 3 over 2 is negative, have the same coordinates. Why do they have the same coordinates? Because they are both reference angles. So this angle is 30 degrees from 180 degrees, and this angle is also 30 degrees from 180 degrees. That is why they have the same coordinates. So reference angles are basically angles which have the same coordinate values, except the signs will be different because they are in the different quadrant. That's what we mean by reference angles. So when I do some of these problems, it will get clearer, but let's quickly look at these So for example, in quadrant 1, when you talk about quadrant 1, theta is basically going to be just theta. Because like I said, this is 50 degrees, this is theta, this is basically we're talking about reference angle. So in quadrant 1, the reference angle is just the theta. But in quadrant 2, like we said, 150 degrees, you're subtracting from 180, so it's going to be 180 degrees minus theta. So 180 minus 140, or remember, if you're talking in terms of pi, it is pi minus theta. Okay, now let's look at quadrant 3. In quadrant 3, basically, you're looking at the distance from this. This is my reference angle. So if this is my theta, which actually this is my initial side, this is my terminal side, but you're actually looking at this measurement. And what is this measurement? This is the larger angle. So it's basically going to be, if this is my theta, so it's basically theta. So let's take numbers. Let's say this is 200 degrees. So what are we looking at? Our reference angle is 200 minus, how far is this from 180 degrees? It is 20 degrees. So how do you measure this? 200 minus 180, or theta minus pi, if we are talking about it in terms of pi. And the fourth quadrant you're actually looking at, so this is my theta, but your reference angle is the measurement of this. And how do you find this measurement? 2 pi or 360 minus theta, because that's what this is. So you subtract from 360. So let's say this is, it has to be after, let's say this is 300 degrees. So 360 minus 300, this will actually be 60 degrees. So 360 degrees minus theta, or 2 pi minus theta. So that is how you calculate the reference angles. Okay, so let's go ahead and quickly look at a couple of problems. I think I did both of these sort of when I was explaining it. So 60 degrees is in the first quadrant. This is my theta. And my reference angle, which will also be basically 60. Okay, 140 degrees. So we know that 140 degree falls in this quadrant. But I'm interested in the reference angle, so this becomes my reference angle. This one, let me highlight that, because the distance from 180 degrees. So basically 180 degrees minus 140 degrees equals 40 degrees. So my reference angle is basically 40 degrees, because this distance from 180 degrees. This distance from 180 degrees. Okay, let me keep going and do a couple more, and then we'll stop. So here we are looking at 220 degrees. Where does 220 degree falls? It falls, this is 180 and this is 270. So it has to fall here basically. So it will be somewhere here. And how do you find the reference angle? The distance from 220 to from 180. So my reference angle is going to be 280 minus 180. So 40 degrees. So this is also 40 degrees. So what do you find? 140 degrees, which is 40 degrees from here, will have the same coordinates as 220 degrees, because they have the same distance from the x-axis. That's why. But the only thing that will be different is the positives and the negatives, because they are in different quadrant. And let's look at this. 340 degrees will be in this coordinate. I'm sorry, this quadrant. And the distance from 360 is going to be 20 degrees. Okay, I'm going to stop here and then we'll start recording in the next.